In the program, this talk is titled Next Level Virtual Machine Maneuver. I emailed the organizers a few weeks ago, but the programs were already printed out, so there was a slight topic change, but it's still pretty close. So instead of Next Level Virtual Machine Maneuver, it's actually Next Level Testing, which is kind of a level up from this. As I was writing the previous talk, I realized it's kind of more of a very specific, like, here's how you do this, and here's how you do this. And you're all pretty smart, so you could learn that in a blog post. When I go to conferences, I like hearing more about ideas as well as things I could take away and use at work. So I'm hoping this talk delivers both of those things. So very quickly about me. My name is Mitchell Hashimoto. This is my Gravatar Twitter handle and GitHub URL, the best places to find me online. It's not really important right now, but I am one of the creators of Vagrant, if you've used that. I work at a company called Keep, and we do mobile advertising that looks a little bit like this. And I wanted to thank Engineered for helping me with my work on Vagrant and also getting me out here to talk. So in 2010 at Gogaruko, Rain, you might recognize him from the panel, Rain gave a talk called Real World Testing, and he did a really good job of kind of explaining the landscape of test frameworks within the Ruby world, covering RSpec, Cucumber, test unit, all those things, as well as talking about what TDD is, what BDD is, and so on. It's kind of an entry-level view into testing, and if you want to learn more about that, you should really watch this talk on Confreaks. But my talk is kind of the next step, or kind of a sequel to this talk. I don't cover beginner topics at all. I'm going to assume that you all know how to use test unit, and I'm going to dive right into things you might see in a larger code base or you might run into in real projects after testing for a while. So let's start talking about testing. Yeah. But before we get started, I promise, like, the first 10, 15 minutes is going to be kind of abstract and academic, and then we're going to get into all concrete stuff you can use every day. But I think it's important to think a little bit differently about testing, especially when you start getting into more complicated scenarios. So the question that I want you guys to kind of think about is why do we write tests? I know, at least in my case, I was taught from very early on that you just do it, and it's a good idea because you want to make sure your code runs. But only recently I've started wondering, like, why am I writing this test specifically? What purpose does testing have? So one of the most common answers I get, or the top answer I get, is stability, and it's totally a good answer. You want to make sure your code runs, you want to make sure it works, so you write tests for it. But if you're agreeing with this, then I want you to think a little bit deeper and think why. Why do we care about stability? Another answer I get perhaps is performance. Our tests are a very quick way to verify that some methods are taking a very long time. If you might have performance tests, or you might just see like that one dot is taking a little bit too long to show up. And again, this is a good answer. And again, I want you to think one level higher and think, why is this important at all? And the third most popular answer I usually get is to test bug fixes, to verify we don't get regressions in our code. This is kind of hand-in-hand with stability. And once again, why does this matter? So we have these three things. They're all very good answers to why we test. But I think there's a more general reason overall to why tests are good. So what I came up with, or why I think that we write tests, is to assert there's a certain value in our code. Because as much as we care about code beauty and making sure it's very modular and easy to extend and all that, our code is worthless. The code by itself is not why we're getting paid. We're not being paid to type on a keyboard and write code. The business people, the suits, your managers, they don't care about the code at all. And especially end users. When I use a website, when I use Twitter, when I use Facebook, I don't care what is going on behind the scenes. I just want to see something work. So what is money is the business value that your code is giving out. What everyone sees is what your code does, not how your code's written. So we're really writing tests in a way to assert that we're getting that value that we expect out of our tests. And that's kind of abstract, but we're going to go a little bit further. There's a study in academia called information theory. It's a very, very broad topic. I don't think anyone would describe themselves as an information theorist, probably a subfield within that. Some things information theory, well, what information theory is the quantification of information, treating information as a quantifiable value. And some concrete subfields are data compression, a lot of electrical engineering, signal processing, natural language processing. These are all very important things, but the abstract notion of information theory is very, very interesting. So in 1928, a professor named R.L. Hartley published a paper. I think, actually I have the URL down there. Yeah, it's titled Transmission of Information. And he made a groundbreaking, in terms of information theory, a groundbreaking idea. And the idea, it's a little bit dense, so I'll go through it a few times. The idea was that information could be quantified as a log function of the probability of an event occurring. So I'll just say it one more time so you could think of the parts. But information could be quantified by the log function of the probability of that event occurring. So in more layman's terms, if something has a high probability of happening, we don't learn that much from it because we see it all the time. And if something has a low probability of happening, we're going to get a lot of value from it because you don't see it that often, so a lot more things are going to be new to you. And when you put it that way, you kind of think, well, that's kind of common sense. That makes sense. And it does. But and in general, I think people say this makes sense, but it's funny because when it comes to testing, when I work with a lot of developers, when I was a consultant for 3 years, so I saw a lot of different teams. I don't see a lot of common sense when it comes to testing. It's like we forget this idea when we test. I see a lot of unnecessary time and money spent on going for 100% test coverage when you're testing things that are not giving you that much value in return. And so the guiding question that, especially once your test suite gets larger, when the stakes are higher, that you need to think about is how much value are you getting out of your tests? And if you could quantify that, then you could say, this test just isn't worth writing right now. And this test, which will maybe test this thing, I should do that instead. So we need to test properly. In small libraries, when your code base is small, it's easy to not see the issues that come from wasting time on tests. But as your test suite gets larger, as you have more to do, as you become a busier person, it's very important to optimize and think about your tests. A couple good points to stand by is if you're succeeding too much, if your tests are passing too much, it's probably not because you're some great holy programmer, because we all make mistakes. It's probably just because you're testing the obvious things. You're testing things that you're expecting are going to pass. And of course, we don't know what's not going to pass. So one way to do that is to move from, say, a unit test level to an integration test level, or vice versa. If you're succeeding too much at one level, move to another level of testing. And another important point is we gather the most information through optimizing both failure and success. If you graph out Professor Hartley's function, you get this upside-down parabola, and where the x-axis is probability of something occurring, and the y-axis is the value that you extract. And so the maximum value you get is at 0.5 probability. If you think you're going to succeed as much as you think you're going to fail, you actually have no idea what's going on at all, and you're going to learn the most out of everything. And that's what you attempt to achieve through tests. So that was the academic, floaty 10 minutes of the talk. So now let's talk about real concrete testing and how we see value, what value these tests are giving us. But more importantly, let's not talk about exactly how you write each test, but let's talk about the ideas behind the test, why you would choose one over the other, and the benefits of each, how all these work together. So what I'm going to be introducing aren't new ideas. I don't at all claim to be smart enough to come up with these on my own. These are ideas that I've seen from other communities. I am a full-time Python developer, so I do that, and then I also do a lot of JVM work, so I see Java stuff. So these ideas come from Java, Python, my work experience, and personal experience. By personal experience, I mean open source. And so let me quickly give a couple qualifications of why I'm even qualified to talk about this subject, so at least maybe you could believe me a little bit. My first qualification is Vagrant, my open source project. It very quickly is a tool which manages the automation and lifecycle states of virtual machines for the purpose of development. And it is used, at least in part, by all the companies listed up here and many more. Like Tumblr and Eventbrite and Barack Obama use it for their entire website, and then Adobe and Living Social use it for parts of the development. But this is just a subset. And some hurdles that I have with Vagrant is it has huge external dependencies. It uses VirtualBox as its virtualization layer currently. And if my communication with VirtualBox breaks down, then the whole project doesn't work. So I need to be able to test that. Unit tests aren't enough for me. But the integration tests are extremely slow. Creating one virtual machine, acceptable. Creating hundreds of virtual machines for the purpose of testing, extremely slow. I have around 50 integration tests right now, and they take around 4 hours to run. There's a lot of OS-specific edge cases that I need to, again, I'd like to at least verify. For example, for some reason on OS X 10.5 and earlier, the exec system call doesn't work very well with Ruby, so I have a workaround for it, and when I push a release, I want to make sure that the code that invokes that is continuing to work. And Vagrant's made to run in any modern environment, so it should run on all your laptops. It's designed to run on all your laptops, and I only really work on a Mac. So again, when I push a release, it would be nice to know that Vagrant works in every environment that I intend it to work on. And more recently, there's a higher cost for mistake. If I make a mistake and I push a broken release, it might damage my credibility. That's less important to the more important fact that it could damage the reputation of the project itself. A lot of people, only recently, these big companies have been moving on Vagrant because they've seen it work for the past 2 years. And if I push something that totally breaks their whole development team and causes them to be unproductive for a day, then they will never touch it again. And my second qualification is, I don't know why it says credentials, but my second qualification is my work keep. Like I said, we do mobile advertising, so we're mostly an API shop. We don't see a lot of traffic, but 500 million API calls a month. It's an okay amount. There is real money at stake in this case for mistakes. There is real credibility, important credibility, especially as a startup, at stake. And there's also potential legal trouble. Like we have some contracts where, for example, we're brand partners with Carl's Jr., and we're developer partners with an exercise app. And it's in our contract that if we show a Carl's Jr. ad in an exercise application, then we're liable to be sued for up to like $500,000. So we need to know when we push code that our algorithm will not show that ad in certain games. So at this point, with all these things, with all these ideas, we need to do a little bit better. I realized in my testing, I need to think about things a little bit differently because there's a lot of things to test, and I want to test all the things, but I want to do it efficiently, and I want to do it correctly. So I'm going to quickly shotgun out the ideas I'm going to talk about so you could quickly see the list, and then I'm going to go over each one in detail. So I think that's it. These are what I'm going to talk about today. Okay. So the first thing I'm going to talk about is integration testing. I love integration testing. It's what I do most nowadays. So when I say integration testing, I mean black box testing. So here's a real valid integration test. So I echo something into foo, and I cat foo, and my test here in this case would assert that I get hello back, because that's what I put into the file. And this is a valid integration test of cat. I don't care how cat works. I don't care how fast it works. That's not the purpose of the test. I just want to know that given some state of the world when we start, I get this state of the world when we're done. And the purpose of integration tests is you test against real external dependencies. So this is, if you don't do this, then the whole test is kind of useless. You need to make real networking calls, real file creation. If you can get it, you should use real data, and there should be no access to internal code. The integration test should not be able to access internal libraries at all. And this is all very important. And in the case of real data, what I mean by that is, for example, for the Selenium tests for my work, we have a script that pulls in a subset of production data, anonymizes it, and uses that. Integration tests are the best way to test platform-specific edge cases and also to find platform-specific edge cases because they are running through your application and your website in ways that the end user would use them. So they find the edge cases that you actually should care about. And the best way to do this is virtual machines. And the cheapest way to get it going is to use Vagrant, because you could run multiple OSs on your own machine and run the tests in there. As you get up and running more, CI, not that hard anymore, and pretty inexpensive as long as, if your project is big enough to want to test so many platforms, then CI is relatively cheap. And integration tests are the best way to get the biggest bang for your buck. Usually when you start a library, so do it early, that's important. So when you start a library, you know what that library, how you want it to work. So later today, Tom Preston-Mortar is going to talk about README-driven development, and that's usually because you know how you want it to work, so you could write that README first. Likewise, you could write tests asserting how you want it to work, the whole thing, and that'll start verifying it very quickly. And no matter how good you think you are, or how simple the library is, and you think you've got it going, the internals are always going to change. Every internal library when you start, or internal class when you start a project, is going to change at some point. And if the first thing you do is start writing unit tests, you're going to have to rewrite all those unit tests. And this is where that value thing comes in. When I see a lot of people that I've worked with just start hammering out unit tests. Like if I start unit tests early and I test each method, then it just becomes easier for me later. And that's one way to look at it. The way I see it is those unit tests aren't really providing much value because your internals are going to change later anyway, so why not test the whole thing? And your integration tests almost never change because you have some purpose in mind, and that's what that thing's going to do. So write your integration tests first. But I won't lie, integration tests are horribly slow compared to unit tests or other sorts of tests. But don't worry about it. I'll talk about fast tests and slow tests later. Just write the integration tests. Okay, so some people think, I just include this because some people think that integration tests are different than regular tests. And so I include a real example. This is a valid integration test. It just uses test unit. I only use test unit, really. And this is an integration test for Vagrant that calling Vagrant-V will return the proper version. So you can see that it's pretty much just the normal unit test except for two helpers. There's the execute method that's going to execute it on the command line like a normal user would that returns the exit code, standard out, standard error. I do some assertions, and then remember that integration tests cannot access internal code ever. So I do pass in a config JSON, which includes some things like the version, which I need to know in the test to assert. So I assert that the version is equal to that instead of looking in the library of the version, because it shouldn't do that. Breaks the isolation. And running it has to be simple. If you don't make your tests simple to run, no one's going to run them. So I'm a really big fan of just running the file to run the test, and that just works with test unit. Okay, so fast tests versus slow tests. I don't know who said this. I don't know if anyone ever said it. Well, I say it all the time. But if you don't run the tests, then what purpose do your tests serve? Like I said, I was a consultant for 3 years. I've seen probably like 50 Rails projects when I was doing that. And there was, I would say over half said, look, we have an awesome test suite. And then I would see all their developers just committing. And I was like, what's the point? You don't run the test, what's the point? So at some point, your test suite will become slow. And I don't know why this is in the Ruby community more than other communities, but Rubyists tend to have this idealized notion that every project you're going to be able to run every test before every commit, and you're going to have this awesome like stable on commit push. And really the pattern that I found is as your project reaches a certain size, or if your project is worth anything at all, your test suite is just going to become slow. You're going to have integration tests. Those are always going to be slow. You're going to get thousands of unit tests. Those are going to become slow. So you can't be expected to run every test before every commit. So something that I've been doing in practice and at work is establishing a subset of my tests as fast sanity tests. These are tests that are run before every commit. They should be very easy to run because you want all your developers to run them. And they should contain a WTF subset of your tests. So another example is sometimes I work with developers and they're like, yeah, we have this full test suite and we can't run them before every commit, but we run these tests because they're fast, so we just run these ones. And the rest go somewhere else. I don't think that's enough. I like to get a subset of my tests that at least tests a good chunk of every subsystem or module of the project, so that when you do run the tests, if you have some big some big WTF going on, then it'll catch it, and that's the real purpose of these sanity tests. So as an example, this is how I run my tests. I only use mini tests. It's pretty easy to do it. So once you have your fast sanity tests, you still need to run your full test suite at some point, and hopefully very often. But you shouldn't do it on your own computer because that's hurting productivity more than helping. So you should move the full test suite onto a CI machine. There's really no excuse anymore. CI is getting really easy compared to a year ago, and especially 2 years ago. CI, I'm pretty sure like my little sister who's like 10 could set it up. Jenkins is like WordPress for CI. You just like run it and you get this GUI and you click around and suddenly you're testing. So you should be able to figure that out. For Ruby, Travis CI is amazing. It's very new, so if you have some problems, that's a disclaimer. But it's very cool, and you should Google that if you're using an open source Ruby project. I don't think it's useful for private projects. And if you need a lot more customization and you're kind of brave, BuildBot is what I use, and it's brilliant. The comparison I like to make is Jenkins is to WordPress what BuildBot is to Rails or some web framework. So Jenkins is a full stack solution. You just install it and it runs. BuildBot is more of a CI framework, so you have to write code. In this case, you have to write Python code, and you build your own CI. You have a repository, and you kind of build your own CI. But with BuildBot, you could configure everything, and they handle all the master-slave work distribution, all that for you. So one caveat to fast sanity tests and to CI and all that stuff is targeted tests. If you're fixing a specific bug, you should run that test at least, or the test that tests that bug before the commit. And I hope this is common sense, but I mention it just in case. And again, it should be simple. These examples don't really mean anything, but they're just to show it should be simple. There's other options when you have fast tests and slow tests. Parallelization and test marking, and I do talk about both of these, so just going to ignore them for now. And actually next, I think, is marks. So test marking. This is something I've never, ever seen any Ruby programmer do. And they're basically test annotations or test tags, which when I first saw them was really gimmicky, and I was like, personally I hate tags. I've never used tags for any meaningful purpose anywhere, except maybe in this case. So here's the example from Python, and this is something that I first saw in PyTest, and now I try to use all over the place. So in Python, you'll have a test. Maybe this is testing a parser, and it's testing that it could parse a string that has underscores in it. And then Python supports first-level function decorators. So I'm decorating the function with a mark, a tag, which is issue 29. Maybe this test is part of issue 29. And to run it, you would do something like this. This is how you actually run it in Python. It kind of fuzzy matches the tags. So why is this useful? This, again, when I first saw this, and maybe a lot of you are thinking this, I was like, that gimmicky, not really useful, not a power tool. But it is one of the most important tools I use now in testing. It's really useful for fast test and slow test marking, for sanity test marking. I like to keep, and most projects I've seen like to keep their tests in a structure that matches their namespace layout or subsystem layout or something like that, and that makes total sense. So you don't want to have tests/WTF for your fast test or something. Using marking, you could just mark some tests like fast or sanity, and then when you run them, it just runs those tests, and the tests still live with the system that they're actually testing. And this is great. It's very useful for plugins. I intended to put an example here, but I don't have one. But the example that I use it for is, I haven't used Rails in like a year and a half, but when I did use Rails, I remember that on every unit test, I think it tore down and created a new database for you, or something like that. And in practice, when I'm testing my models, I don't need a database, an isolated database that often. A lot of the things I could just test in memory. So at work, what we do is we mark the tests that do need a database with isolated -db, and when the test runner sees that, it calls something which sets up an isolated database just for that one test. And so you could imagine you could use marks for all sorts of things. Another thing I'm using it for, and this time in Vagrant, is I'll mark a test with OSX_10_5, and that test will only run on Mac 10.5 because it's not testing anything meaningful on any other platform. So that's useful. Issue tracking is very cool. A lot of projects create separate files like test issues /825.rb to test like issue 825. And that's very cool. It's very easy to find an issue for a specific issue number, but now you're moving your tests out of the system they're actually testing into all these files. And that's one problem I've always had with it. With test marks, you could keep the tests in the systems they're actually testing and just mark them with the issue that they're working with. And that way it's very easy to, if you find a regression or something, you're like, oh, this is a regression from issue 49, you could just run test issue 49 and it'll run all the tests related to that issue. So in Ruby, this would be a good time to say, for this talk, I made 4 libraries that should never, ever, ever be really used in production. They're just proof of concepts for these ideas that you could just get down and play with. And they're all extensions to mini-test because that's what I like to use in Ruby. So I made, and this is all on my GitHub page, and the links will be at the end. So I made mini-test mark for Ruby. It looks like this. It looks exactly like the Python example. So there's a Python example turned into Ruby. And it does some kind of unholy things to Ruby to make this even work. So you just mark things, and you can have multiple marks, and you have the test. And then when you run it, you just specify it in an environmental variable, and it runs that test. For people who want to know, this uses method added hooks to do this. It's brittle, but it works. And that's it for marks. So the next step, next thing I want to talk about is parallelization. There's actually a talk on test parallelization, and it was good yesterday. So there's going to be slight overlap. So parallelization in Ruby, I never did it when I did Ruby full time, and I still do Ruby a lot for Vagrant every day. And it still seems that parallelization hasn't really caught on, and it's kind of a strange thing, because like when I started using Python, every developer I talked to was like, what do you mean they don't? You just do it. You just turn it on and it just works. Like you don't have to do anything. It just parallelizes. And I was like, well, no, it doesn't work because like things break, and they didn't understand this concept at all. It just like it was news to them. So then I was like, well, why don't we parallelize in Ruby? It doesn't make any sense. I mean, I know there's a GIL, but Python has a GIL too. They just make more processes. And so I was like, why don't we do this? So here's a Ruby test, syntax error Ruby test, and there's a lot of problems with this test. It was a normal test, I think. Show me this a year ago, and I would have been like, that's fine. But there's actually a lot of problems with this. The first problem, for example, is you're always opening a file named test file. So if you parallelize this test and you have multiple tests, then the teardown is going to destroy that file, and some test is going to fail at some point. A better thing in this case to use would be like a temp file. Another thing is Ruby, this isn't Ruby's fault, this is just this kind of a standard practice, uses setup and teardown, and setup and teardown, in my opinion, just push shared state. And you could use setup and teardown properly, but I think it makes it much easier to fall into a trap where your tests aren't easily parallelizable. So in this case, it's assigning state to an instance variable. You have to create a new instance of the test class in order to parallelize it. And especially with JRuby and Rubinius, it'd just be much cooler to instantiate the test once and just tell it to like shotgun out all the tests in that class. So really the general idea, the general lesson from that is that shared state is bad. This is a general lesson for concurrency and parallelization in general. So I think setup and teardown are inherently dangerous. And I don't understand why instance variables ever took off for test state. They work, but I don't know why that ever became popular. So if you push down all your isolation down into the test level, that specific test, then it becomes very easy to parallelize. And this is what people just do in Python. So here's crude attempt number 1. The first 2 things I show you are really nasty, and you're gonna you'll never want to do this. So let's get rid of the setup and teardown blocks, and let's move the state just into each test. So in this case, it's doing what the setup and teardown block did, but moving it into the test, and then the teardown is an ensure at the end. Of course, now you're like, well, now I have to do that on every single test, and setup and teardown was made as a way to dry up your code and remove all that setup back into these things that are hooks. So yes, I agree. This is bad, but it's a step in the right direction. So crude attempt number 2, let's take everything, all that setup and teardown, and let's move it into a method that sets up our state and passes it into us. And this, just like a file open block, this will do all the setup and then do an ensure at the end of the block to make sure that we get proper teardown. This is not bad, but maybe some of you notice it. This kind of looks like a function definition, right? We're just calling that thing. So let's pull that argument up, and this is better. In this case, this is something that the Python world calls funcargs, and what this is doing is passing the state in as a parameter to your test, and then it's responsible for cleaning it up after. And this pushes all your isolation down into your tests. It's pretty magical. I'm not gonna try to argue that. It's pretty magical, and I made it work in Ruby. I don't know if this is a good idea for Ruby, but I think test level isolation is a good idea. So there should be a good way to do it in Ruby. And the way it works in Ruby is you define some method that matches a certain signature. So in this case, the magic key is to prefix it with minitest underscore funcarg. Then you do 2 underscores and then the parameter name, and then you return what it's gonna do. Then you define your tests, and when you run it, it just works. But when you run it, what's happening is the test runner sees that there's a parameter and it's actually named instance. And this is where the crazy magic happens. It sees it's named instance, and then it looks up a method that's available in that scope named that underscore instance, and then it calls it to get the value. So this is why it's psychotic in Ruby, because actually getting the argument name is completely non-standard between every interpreter, every VM. In Python, it is standard, so they do it. And then in Python as well, I didn't do this in Ruby because I think this proof of concept gets the point across fine. But they also pass in a method to here where you could set up finalizers and all sorts of things, so you could do proper cleanup, and each state handles its own cleanup. And I love funkargs. It's very cool. And now you parallelize, and it's free. You just turn it on, and it works every time. And there's a third library that I wrote, Minitest Parallel. And you just require it, and you run it, and it'll actually parallelize all your tests. And it's free. That one, actually, if you want to run it in real, it's fine. That one's fine. And I don't know, there's a lot of tests, a lot of talks on optimizing your tests, and parallelization is the easiest way to make your tests faster. You go from tests taking 4 seconds in a single process to a computer with 4 cores, and they will take 1 second. They speed up pretty much linearly in every case. And so this is super helpful when it comes to CI. Just parallelize your tests. Okay, so the third thing I'm going to talk about, or fourth, I don't know, is performance. And when I say performance, I'm not talking about test performance. I talked about fast versus slow tests. I'm not talking about test performance. I'm talking about performance as a kind of test. In a lot of applications, you would say performance is a feature of the program. In my work, we do mobile stuff, so we need low latency. So our limit is an API request cannot take more than 30 milliseconds right now. That's our limit. So we have tests to assert this. So what you really want is an assert that's like assert takes less than forever, and then you just run some code. But unfortunately, performance is a different kind of test. Asserts are instantaneous. Look at the instantaneous state of something. And performance, you actually want to look at performance over time. It's not an instantaneous view of the world. It's a timeline view. So this is the fourth and final library I wrote called Minitest Speed, and it allows you to define a speed test. And in a speed test, it just runs the test and times how long that test took. I use a funkarg here as well, and it excludes the setup time of the funkarg. So just the test body. And then you run it, and just as the example, mine outputs the name and the time it took to run it. But all you really want is something that's easily parsable for the purpose of graphing it. What you want to do is you want to run this on a CI, and you want to graph it. And there's a ton of graphing libraries out there, and you just pump this data into a database and you graph it, and you make sure that it follows a certain curve. So to wrap up, integration tests, write them first. You get a huge value initially, and then the value trails off, and then unit test value starts to rise. But write integration tests first, then move down to a lower level. Fast test versus slow test. Establish a subset of your tests that test every part of your system that are fast enough to run before every commit, and do that, and move your whole test suite off to a CI. Marks, they're really cool. I don't know if there's a good way to do them in Ruby, but there's a lot to be learned from them. Parallelization, test isolation. Try to move your state down into the test level and just flip a switch and start parallelizing. You'll get biggest speed boost you could get. And performance tests. Performance is a feature of your code, at least in some regards. So you should start testing that you're getting the right performance out of your code, because if your site is taking 500 milliseconds to load, then you're going to start losing, people are going to start dropping off. And that's it. So here's all the GitHub URLs to the crazy libraries. And really the code in all of these is crazy. And that's it. So thank you.